Hello, my name is Matthew Greaves.
And my name is Vincent Marois.
And we have decided for our circuit, we have chosen that of the FM radio receiver. Now, we're going to be talking about multiple things during this presentation. We're going to start by talking about specifically the difference between AM and FM radio waves and how they work, as well as providing a general description of some of the components that you may find in an FM radio receiver.
As well, after those two parts, I will describe a different kind of circuit to receive some FM wave and the differences between them, the advantages and disadvantages of each of one. Then we'll go into a detail of the particular circuit that we want to create for this project.
There are two major types of radio signals. The first one that came out a very long time ago is called AM radio. The idea behind AM radio is sort of shown with our kind of a bit poorly drawn picture right here, is essentially the idea that the amplitude, specifically of the carrier wave of the radio wave, is modulated. In other words, it increases and decreases and increases and decreases at a steady rate. Now, there are a lot of problems associated with AM radio, such as the fact that a lot of household appliances will cause it to have lots of noise. The signal won't be as good. Now, in the 1930s, FM radio, in other words, frequency modulation radio, was created. And the idea behind that is rather than modulating the amplitude, it modulates the frequency. As you can see, higher frequency here and lower frequency. And again, it does this at a constant rate. Now, one of the other cool things is the fact that FM radio operates at an 88 to 108 megahertz frequency rather than AM's 535 to 1705 kilohertz. This allows FM radio to reach a lot larger distances, and also it cuts down on interference. So this diagram that we've drawn on the board is essentially a very, very general description of what, or at least a general kind of functionality of an FM radio receiver. So we start over here with the input antenna, and go to the next component, which is an RF amplifier. Now, the idea is that radio waves are really fairly low power, and the RF amplifier essentially increases the power of the wave so it can be worked with. Our next point is essentially the tuner. Now, this can be made in various different ways, which Vincent will explain in the next section. But the very basic kind of form of it is essentially it allows you to tune through the channels, essentially, to pick up the different radio stations. Again, it can be done in a multitude of different ways. Third component is the filter and demodulator. The idea of this, we've combined it into two components just for simplicity's sake. The filter filters out any sort of excessive noise, and the demodulator essentially works to create, as I showed you before, the frequency modulates back and forth, and that's how FM radio essentially is transmitted. And the demodulator essentially will take that modulated signal and put it back into a signal with constant frequency. The last part is the audio amplifier, and this will simply amplify it to a point where it can be used with whatever speaker you're using, anything like that. Then right out here is the end that outputs to the speaker or the headphone jack or whatever sort of audio device you have connected up with.
Okay, so the first kind of circuit that we will speak about is the crystal radio receiver. So the advantage of that circuit is that it doesn't need any external source of power. So what it means is that the radio wave that it will receive will power the circuit. The disadvantage of that is that the output to the speaker or to the AirPod is pretty low, so it's really hard to hear the sound from those waves. So how it works is that the circuit will receive an input to the antenna, and then it will be able to modulate this input with a diode. So it's basically just getting rid of like one polarity of the circuit. So if we look at the input and output of it, it could look something like this, and the output, because of the diode, will end up being something like that. So as you may have noticed, this kind of receiver will work only for AM waves, so like the waves that are modulated using the amplitude of them, and it won't work with FM wave. It requires a more complex circuit that we'll speak about soon. Okay, so now we'll see a different circuit that will be able to receive the FM waves. So it is called a reflectional receiver. So how it works is that it will receive the input from an antenna there, and then it will tune the input to be able to receive whichever FM frequency that you want to listen to. Once it tunes the input, it will go into an amplifier to amplify the signal so it can actually listen to it. Afterward, the output of the amplifier is split into two. The first branch will go to a low-pass filter and then go to the output. I will speak about it a bit later. The second branch goes to a high-pass filter, then to a demodulator, and goes back, feedback before the amplifier. So if we look into detail a bit more, let's say that the FM wave has a regular frequency like this. Okay, so there's actually no sound on that one, on the signal. So once we modulate this, it will look more like that, and then with some higher frequency at some point to differentiate between different sounds. Okay, so this signal will go to the tuner, to the amplifier, and then when it goes to the high-pass filter, it will get rid of those higher frequency to go back to that normal frequency, and then it will demodulate it and subtract it from the tuner to try to get rid of it to just keep the actual sound that we want to listen to. On the other end, the low-pass filter, instead of getting rid of the red one of the normal frequency of the FM wave, it will try to only keep the higher frequency. So it will be a blue, just the blue one, and yeah, it will pretty much be this the output that we want to listen to, and we'll get rid of that other normal FM frequency wave. Okay, now we'll go over a more a modern circuit to receive the FM wave, and it is called, wait for it, super heterodyne receiver. So basically what it does, it will take the input again, it will amplify it as all the other circuit do, and then to be able to tune the receiver input, it will use an oscillator that will oscillate at the frequency of the desired wave that you want to listen to, and it will mix it with the input. After that, the circuit will need to filter the input from the mixer, then amplify, and then it will demodulate, amplify the audio signal, and then we'll be able to listen to the radio wave.
So behind me on this board is kind of an example of the kind of circuit that we want to build, like Vincent had described using the block diagram in the last little thing. Yeah, this is an example circuit. So the idea being is that this section is essentially the oscillator and the mixer component of the circuit. Now this right here is one of the more important components, and that is the variable capacitor. And the idea behind that is This thing, you're all able to essentially increase or decrease the capacitance of this, usually using a small tool like a screwdriver. And this will allow you to essentially tune through the channels of the radio and essentially find the radio station you would like. As you move over here, you have different components such as the filter in here, as well as consecutive audio amplification. Now these stages will also filter out any excess noise or frequency that you want, as well as amplifying the sound. This right here is the headphone jack, so specifically for this circuit, it allows for headphones. However, depending on what kind of circuit you want, you could also use a circuit. The power source is right over here, and as well as your basic on and off switch, just in case.
Okay, so that's the end of our video. We are hoping that you were able to learn something and that you enjoy watching our tutorial on the FM and AM radio waves.
Thank you very much for watching. We appreciate it.